Alright, in section 11.2 we talk about taking derivatives of exponential functions. The first one we take the derivative of is e to the x. The interesting thing about e to the x, exponential function as it is that the derivative is exactly the same function. Because if you take the derivative of 1, you get a slope of 1. Take the derivative of 2, you get a slope of 2. Derivative of minus 1/2, you get a slope of minus 1/2. And so it's very interesting that the equation that you start with, its derivative is exactly the same thing. So they ask you to take the derivative of 3e to the x plus 4x minus 11. These two aren't that hard because we've been doing derivatives for a while, but this is the new one. 3e to the x, well, the derivative is just 3 times the derivative of e to the x, which is just e to the x. Derivative of 4x is 4, derivative of 11 is 0. Now there's a rule here that says if you have e not just to the x, but e to a function, meaning more complicated than just x, you get back what you started with, but you also get back the derivative of the exponent. So if we have e to the 4x cubed, we have e to the 4x cubed times the derivative of 4x cubed, which is 12x squared. When you have this guy, you've got a product rule because you got 3t times e to the power of t. Okay, so you're going to use the product rule. So you got the first guy untouched times the derivative of the second, plus the second guy untouched times the derivative of the first. Well, the derivative of the second guy is e to the u itself times the derivative of the exponent, which is 6t plus 5. And over here, the derivative of just the 3t is 3. So now you bring the 3t and the 6t plus 5 out front, and you follow with this guy, plus 3 times this guy raised to the power. This is the quotient rule. So we're going to take, we got the bottom times the derivative of the top, which is just 1, minus the top times the derivative of the bottom, which is itself times the derivative of the exponent, or 3, all over the bottom squared. Now you can factor out e to the 3w out of both of these, and you're left with this part here. And since this is e to the 3w squared, it's e to the 3w times e to the 3w, and you can cancel one of those e to the 3w's, leaving you with a simplified form there. E to the ln of x, well, the derivative is just e to the ln of x times the derivative of ln of x. Well, the derivative of ln of x is 1 over x squared times the derivative of x squared, 2x. So you get one of the x's, well, you get 2x over x squared, and you get that e to the ln of x squared. But you can cancel one of the x's. Now keep in mind also that e to the ln of x squared is just x squared. Now why is that? Because you can write e to the ln of x squared as e to the log base e of x squared. That's the same thing. And when this number and that number match, your answer is just this guy here. So this whole thing reduces down to just x squared, which is derivative is just 2x. That's why up here the answer is 2x. At this point, if you simplify this, you get e to the log base e of x squared. So this part here is just x squared. And when you replace it and cancel with the x below, you get 2x. They ask you to take the derivative of this exponential function, so you get 100 e to that power times the derivative of the exponent, which is 0.08. And then 0.08 times 100 is 8, and so there's your derivative. You plug in 1 and you get $8.67, which means after the first year or during the second year, this is how much money you'll accrue, or how much money will grow. And then plugging into 10, you get this number here, and that's the amount of money that will grow in the 11th year. Remember, it's always the next one after what you plugged in. Number 5, they give you the revenue function, ask you for marginal revenue, so you take the derivative of this guy, and you got to use the product rule just like we did before. Okay, and so you get this whole thing here, and we multiply the negative 0.01 times the 250 gives you negative 2.5. You got the x, you got this guy, and you bring the 250 out in front of this one. Now if you wanted to, you could pull out an e to the exponent out of both of these, and you're left with just this part inside the parentheses. So now when they ask you to analyze it for 75, they actually ask you to analyze it for 75,000 tenths are sold, but x represents how many thousands of tenths. So 75,000 is represented by the number 75. You plug that in and you get this number, and your dollar amount is the amount of dollars in thousands of dollars. So it's $80.25 thousand dollars, or 80,250. So the sale of one more tent or 1,000 more tents will yield approximately $80,250 in additional revenue. Now what if you're taking the exponent and you take the exponent of something that's not E? It's another number other than E. Well, it's just, it gives you back the number you started with, but you have to follow that with the natural log of that number, A. And if you got a to some function, u, it's just a to the u times u prime times ln of a. So here we got 4 to the x, so our derivative is 4 to the x times ln of 4. Here we got 5 to this function, so it's 5 to that function times the derivative of the function times ln of 5. Now here they give you this guy and ask you to take the derivative. Well, e to the x's derivative is e to the x, and this guy's derivative is just 6x. When you set it equal to 0, it's not at all easy to solve, so we're going to use our calculator here. We're going to graph this. Okay, and I think if you started with maybe a zoom 6 for your graph, it'll give you a standard window, 10 by 10 in every direction. Now if you want to find places where something like this crosses the x-axis, which is where your relative max or mins possibly will be, you do second trace 2, and you move to the left of the point, right of the point, and enter. And so if you do that, here's your derivative. You move to the left of the point, right of the point, and to the point itself, and hit enter. Same thing over here. And you'll get these two x values. Now if you use these two x values on a sign diagram and check with your first derivative, you get plus minus plus, which means you got a relative max at 0.2045, and here's your y coordinate. You find that by plugging into the original function. And here's your relative min and the y coordinate for that. And so here's your original function. You can see that these are correct calculations because you get a maximum here and a min there. Alright, so now let's look at the similar questions from WebAssign. When you take the derivative of 5e to the x, just 5e to the x. Derivative of x is just 1. Derivative of e to the x is just e to the x. Derivative of x to the e, now that's different. You remember with x to a power, you bring the power out front and subtract 1 from the exponent. So you bring the e out front and you write e to the e subtract 1 in your exponent. In this one, your derivative is just itself times the derivative of the exponent. And you might want to write that out in front. This one, e to the negative 1 over x, well that's e to the negative x to the negative 1. If you bring that x up top, it becomes x to the negative 1. So when you go to take the derivative, it's just itself times the derivative of that, which is negative of negative 1, x to the negative 2. And that makes that positive x to the negative 2, which is 1 over x to this positive 2. And this guy is e to the negative 1 over x. Well, that's 1 over e to the positive 1 over x. And you can combine that and write it that way. This one plus this one, this is really 2e to the negative 2x. And this is really just 1/2 e to the 2x. Makes it easier to see what the derivative should be. So you get 2e to the negative 2x times the derivative of negative 2x. You get plus 1/2 e to the 2x times the derivative of 2x. And you multiply those two and you get negative 4, and you bring this guy down and make it a positive 2x. And 2 times 1/2 is just 1, so you just get the e to the 2x. On this one, you're going to use the product rule. So you got the first guy untouched times the derivative of the second, which doesn't change, plus the second guy times the derivative of the first, 2x. And there you go. 21. E to the x squared minus e to the x to the fourth. Well, that's e to the x to the fourth. Subtract e to the 4x, because when you have power to a power, you multiply your exponents. So now what's e to the 4x's derivative? Well, it's itself times the derivative of x to the fourth. Minus e to the 4x times the derivative of 4x. And you get this guy here. Now this one, when you take the derivative, you get 1 over itself times the derivative of itself. And when you clean that up, you get this guy here. This one, the quotient rule. So So you got bottom times derivative of the top, and derivative of the top is 0 plus this guy times 5, minus the top times derivative of the bottom, which is this guy times 3, all over the bottom squared. Now you can factor out a e to the 3x out of the top. You can rewrite the bottom as e to the 3x times e to the 3x, and that allows you to cancel one of the e to the 3x's. What you have left finally reduces to this guy here. Now you can divide this guy by e to the 3x, and you're subtracting your exponent, so you get 2x. And here, when you bring that guy up top, it becomes negative 3x. 30, same idea, it's just quotient rule, it's just more complicated is all. So you get the bottom untouched times derivative of the top. Derivative of the top, this guy is untouched. This guy is going to give you itself times derivative of the exponent, which is a negative 1, minus the top untouched times derivative of the bottom. Derivative of the bottom, that first one is untouched. Its derivative is the same. And that guy's derivative is itself times negative 1, all over the bottom squared. And when you clean this up, the first guy is untouched. Second guy, that becomes positive. That guy I haven't changed, but that guy becomes subtraction. And now what you have there is you have this guy times itself, and you have that guy times itself. So there's your answer. 44, when you take the derivative, you get 700e to that power times the derivative of the exponent. And when you multiply that, you get 63 out front. Now when you plug in a 4, you get $90.30. That means the amount of money that will grow in the 5th year is $90.30. When you plug a 10 in and you get $154.95, that tells you that in the 11th year you'll get a growth of $154.95. 47, they give you the cost function, and x over 600, I wrote it as 1 over 600 times x to make it easier to understand how the derivative works there. So you get the derivative of 10,000 is nothing. And so here you're going to use the product rule. So you got the first guy, 20x, times the derivative of that. Well, that derivative of that guy is just itself times the derivative of 1 over 600x, which is just 1 over 600. Plus the second guy, untouched, times derivative of the first, which is just 20. Now when you clean that up, 20 over 600 is really 1 over 30, and 20 comes out front. So now when you plug in 600 into this and simplify it, you get 40e, which is approximately $108.73 per unit. Now remember, if you want to find e, your e is found right here with the divide key. You hit second divide, and that gives you the e key. You can also use e by hitting second ln. Second ln gives you the e key. If you have an exponent you're going to use with it, that's a good one to use. I just use second divide, and then if I have an exponent, I just type in the hit hat key and follow it with the exponent. 49, they give you this function here. I multiplied by 100 first, and then when I took the derivative, this guy goes away, and this guy, you have the minus 100 out front, and you have this guy untouched, or the same guy, times the derivative of the exponent, which is negative 0.462. Now when you multiply that times that, you get 46.2. Alright, so now they ask you what happens after 1 hour. When you plug 1 into the exponent, into the function, you get 29.107% change per hour. 53, they give you h here, and they give you the derivative. Well, it's just this guy times this guy times the derivative of the exponent. And that times that gives you 79.5. Right. So now they ask you what happens in 2022, where t is the number of years past 2000, so t equals 22. Plug 22 in, and you get this number rounded to 3 decimal places, so that's $255.126 billion per year.